Welcome to RIT Sec, guys. All right. Make sure you join the Discord if you have not. We okay? All right. All right. Please sign in, guys. Sign in is dropped. We will be checking sign-ins for when you want to get pizza later today at 2. All right. Check the calendar as well. Join the RIT Sec mailing list. And now, guys, clap it up for the sponsors. There it is. All right. Keep it going. Keep it going. All right. Thank you, guys. Make sure you follow our social media. You guys can watch the stream on YouTube. Check out our LinkedIn and check out the Instagram. All right, and now for announcements. We have the last day of the mentorship signups. If you guys have any questions, I'm here. We have a few groups. We're kind of stacked now for one-on-ones, so I would definitely look into signing in for groups if you have not. We have some pretty cool advanced topics here, so if you guys are interested in like freelancing or maybe even like phone hacking, we'll see what you guys check that out. All right, if you guys, everyone is all good with the slide? Philip, you still scanning? No? All right. Philip could be your mentor, guys. All right, so we have applications for the CTF Black team as well. If you want to be a challenge author, sign up here. Also, this is the last day to sign up as well. See more at that website. DM OXM Malik on Discord. And also, if you want to be more on the dev side, check out the other QR code to sign up for be a part of challenges in setting up infrastructure. All right. We also have ISTS White Team signups. Sign up here, guys. If you want to help out, if you maybe not a part of Black Team or Purple Team this year, check out, or blue or red, you know. Check out this, be a White Teamer, guys. If you don't know what White Team is, you will be walking around during the competition, helping out Blue Teamers, and also setting up and tearing down the competition. You might also be able to help out Black Team with creating some injects. DM Leah right here if you have any questions. And the competition date is February 27th to March 1st. All right, cool. And now, all new presentation, first time ever. Check out Web3 Security by Arianna Schwartz. Clap it up, guys. All right, we're going to fix one thing. So technical difficulties, guys. All right, favorite class this semester. What do we got, guys? Who's taking 201? Yeah, we have 201. Did they make it more difficult this year, or is it the same? Do you guys know? No? So I heard it was, I heard they changed the curriculum. So, like, I had, like, 4 tests, if I recall correctly, and now they made it where, like, in-person, like, handwritten tests. Am I right about that, or is that 202? If no one knows what I'm talking about, it's fine. But I'm not sure if the professor changed it. That's all I heard, guys. That's the RIT news from me. 5 more seconds, guys. All right, that's all I had. All right. All right, another 5 more seconds. Does anyone know what Web3 security is? No? This is all new topic for people? All right, well, neither do I, so that's why we're here, guys. We're going to learn what Web3 security is. All right, who knows about crypto? Who knows about NFTs? Crypto NFTs, guys, right? We're looking at the, what is that NFT called with the chimp? What is that called? Dumb chimp, or what is it called? No? No one, who has an NFT here? Who has Bitcoin? Who has any cryptocurrency? There you go. All right. So we're going to look into that a little bit. All right, guys, you don't got to listen to me anymore. There you go.
Thank you, Adam. Hi, guys. I'm Arianna. Sorry for the wait here, but we're going to get started with Web3 security. So a little bit about me is I am a master's cybersecurity major. I'm on my last semester of BSMS. I'm the former IR-Sec CA, so hopefully you kind of know who I am already, at least a little bit. And then I'm also a member of WIC and Gymnastics Club. So we're going to talk about yeah. Okay, there we go. Okay, so what we're going to talk about today, we're going to talk a little bit about an intro to Web3. So what is it? What does it do? And then some like very high level, low level blockchain, if you will. And then we're also going to talk about securing Web3, so new risks, familiar vulnerabilities, and then how to secure Web3 products. Okay. By the way, we're going to move through like a lot of stuff really fast. So if you have a question, just ask it when you have it. Don't wait till the end. We're going to be so far past whatever your question was by the end, so don't wait. Okay, just like a heads up, I realize there's a lot of ways you can lose a lot of money in these presentations. So like, I don't recommend you do anything I say necessarily. And if you want to go trade crypto on your own time, that's fine, but it's not my fault if you lose money. So yeah. Okay, so who knows what Web3 is? Even though Adam just like asked that, but I was busy, so I don't know what he asked. Okay. So Web3 is this new evolution of the internet, according to Chainlink, where it's centered around decentralization. The idea is that you have a similar to our current web experience, but it's centered around ownership and cryptographic guarantees. So basically, we want similar internet experience, but on the blockchain is like the idea. And Web3 is kind of becoming more mainstream now, so I really recommend getting into this area right now. Okay, so some pros of Web3. We're going to go over pros and cons. First pro is resilience. So Web3 is decentralized. So over here we have, this is a centralized network. Obviously, this would be like your regular internet, and then this is a decentralized network. So this would be like your blockchain, right? So on our centralized network, if we were to, let's say the white dot is like Google. If Google were to like completely crash, it's down, it's gone. This is like the end of days, right? Like, we're done. It's over. Okay, it's going to be tragic. Now, with our decentralized network, these nodes could be anyone. So, like, maybe one is like a company, maybe one is like, I don't know, your friend or something, okay? Maybe someone here decides to host a node or something. You can. It's just like you make a little cache. It's kind of cool. Maybe someone here decides to host a node, but they do it on the stack, so it like crashes, right? Because, you know, if your node crashes, that's bad for you, but like the rest of us, we're going to be okay. It's going to be fine. It doesn't really affect the entire network just because one person's node goes down. Transparency is another big one. So if it's a public blockchain, anyone can see the code for smart contracts and also the blockchain itself. We're going to talk about this more, but basically if you think there's something sketchy about a contract you're thinking of interacting with, you can just go read the code and see for yourself if it's a problem or not. Sorry. Okay. Next thing. Yes, there we go. Next pro is that you have control on the blockchain that you don't have on the regular internet. So you have control over your data, your digital assets, and your identity more so. So with your data, decentralization prevents one centralized entity from holding all of your information because there is no like overarching authority that could be collecting your data. There's also peer-to-peer interactions on the blockchain. So when it comes to like paying people or something like that with your digital assets, there is no middleman. There is no like you're sending your money through a bank or something. It's I'm sending money from my wallet to your wallet, no in between. And lastly, you have more control over your identity. So there's a thing on the blockchain called self-sovereign identity, SSI. This gives the user more control over their information because of you keep your information in your wallet. And if someone needs to know your age or something, you can choose just to send over that piece of information to whoever it is. And again, there's no middleman, there's no overarching authority, so no one's going to be collecting your information. Okay, there are also some cons. A big one is complexity. They're trying to make it more user-friendly. They're trying to make it more mainstream, but your grandma is not using this anytime soon, or at least mine isn't. I don't know about yours. Also, security is a concern, and I know what you're thinking. Then why are we talking about it, right? We should probably just not do this at all. But anytime there's a new thing, there's going to be new problems, right? And I want to ask you guys right now, what is the biggest vulnerability for any system? Humans? Right. So the biggest concern for Web3 is actually that people are going to do stupid things. You have, with your crypto wallet, you have a public key that's public, right? Anyone can see it. Anyone can like send you things with your public key, okay? Then you have your private key. Your private key proves your ownership of the wallet. If you lose your private key, you have lost all your money because you cannot access your wallet anymore. Okay, so think of like, it's still there, you just can't touch it. It's like if all your money was in a bank vault and the bank vault was sealed and I threw away the key, you know exactly where it is, but you're never gonna get to it. It's kind of like that. There's also a concern with phishing, like there always is. If you give someone your private key, you gave them all your money. It's okay, we all make mistakes, but that's a pretty big mistake to make, and it is a very big concern, especially if you're trying to make this mainstream. You're trying to get less technical people into it, and when you get less technical people into these things, you run into these problems a lot more. I would also like to say with the phishing, did anyone hear about the Bybit hack last year? They lost like billions of dollars, a little bit. Yeah. So billions of dollars, that all started with a phishing call to, now that was an organization, so it's a little different than like you as a person, but it all started with a phishing call. Places don't hack the wallets themselves, they hack the people. Also, if you have your self-sovereign identity information in your wallet and you give someone your private key, congratulations, you just gave them your whole identity. So you really got to be careful with that. There's also a couple other things you have to watch out for, like rug pulls. These are pretty much just like on-chain scams. One example is like with these meme coins. A lot of time people buy these like influencer meme coins or whatever, and then whoever posted the coin can just kind of drain all the liquidity, and you're left with this useless thing and no money, and you paid whoever made it up, and they're rich now. So last is regulation. So public blockchains are open source. There is no governing authority over it. And also, as far as like regulation in the government, the policies we have for the current internet really do not apply very well to Web3, and we're starting to see more regulations already, but we're probably going to start seeing more, I would assume. Okay, now what does Web3 actually do? So, like, now we know what it is, but what can we do with it? So the first thing is cryptocurrency. We can have money online. It's cool. I'm going to say this now, like, Bitcoin is not technically Web3. We'll get into why later, but it is cryptocurrency. So in case you were wondering, these currencies are Bitcoin, Ethereum, Solana, USDC, and Tether. USDC and Tether are both stable coins, which means they are one-to-one with the US dollar. So this is like literally just online money. Okay, it's just digital money. If you were to like pay a business with USDC, that would be more ideal for the business probably than paying them in like Bitcoin, because the thing with Bitcoin, Ethereum, and Solana is that their prices depend on demand. So the stable coins, like it says, they're stable. They're going to be whatever US money is. These other coins are kind of similar to stocks, where like the more people who buy them, the more expensive they get, and the more it's selling, not the more it's selling, but the more people are getting rid of it, the less it's going to be value-wise. And this is like where I think a lot of the ideas of like trading crypto comes from, is the volatility of the money. Does anyone own crypto? I think Adam asked that too, but I wasn't looking. Yeah? Yeah. I'm just curious, and I didn't see who was answering. Okay, so another thing you can do with Web3 is decentralized finance, and we're going to talk about really quick just like what some attributes are, and then we're going to talk about what you can actually do with it. So first thing with decentralized finance is self-custody. With normal money, a bank holds your money for you. With crypto, you have the option to hold your assets yourself in your wallet. We already talked about why you may or may not want to be careful with that. Or you could choose to entrust your assets to an exchange, and they kind of hold it for you. But that comes with its own risks because, like I said, there are attacks, like an exchange could get hacked and their money could get taken too. Next thing with DeFi is that transactions are immutable. So once an action is on the blockchain, which means they're either mined or validated, we'll get into what that means in a minute, but once it's on the blockchain, it's always there and it's always visible. So if I said I paid Leah for dinner and she says I didn't, we can just pull it up right now. Like, it's like Venmo, but there's no like cute little message, you know? Okay, next is it's peer-to-peer. So we already talked about this, but there is no one in the middle. There's no bank it has to go through, nothing like that. It's just my wallet to your wallet, and that's it. Open source, we also talked about this, but code for contracts are always visible. You can always check them. And then code for the blockchain is visible, and technically it's open source. So if you had a really good code idea for the blockchain, you could try to get it accepted and submitted like OpenSSL or something else that's open source. And then it's also digitally native. This is not the same thing as like, oh, I have my banking app on my phone and I click buttons on my phone and it like transfers money to my accounts or whatever. No, there's like a physical back end to your banking app on your phone. With decentralized finance, it's digitally native. It's all online. There's no like physical process on the back end. So what can you actually do with decentralized finance? This is where we get into things that you can lose a lot of money doing, so I would be careful with these things, but you do you. First thing is trading. There's a couple of different ways you can do trading with crypto. You can do spot trading. That's where you buy and sell crypto depending on the current price, and this is very similar to like stock trading in concept, not necessarily in execution. And then other things you can do with trading is there's derivatives. So derivatives are contracts that are dependent on the value of the cryptocurrency. There's two types I'm going to talk about, but I think there's like more in general. One is futures. This is when you bet on if the price of an asset is going to increase or decrease. So if you bet that it's going to increase, that's called going long. If you bet it's going to decrease, that's called shorting. These have an expiration date, and when you hit that expiration date, if your guess was right, then you get paid. If your guess was wrong, you have to pay, basically. So you're just betting on the price of the asset. Then there's something else called options. This is similar to futures, but the trader has the right but not the obligation to sell. So you don't have to pay right away, like if you're wrong or whatever, but this contract does still have an expiration date down the line. Like you can sit on it for a while, but eventually it's going to expire. They are time bound. So eventually, if you're wrong, like if you're that wrong, you're going to lose money anyway. Next is yield farming. This is when you lock up coins for some reason, and then it gives you profit for that. So an example of this is a lot of DeFi platforms like to increase market value by incentivizing that users lock up their coins. They do this because of, like I said, the more people who are getting rid of the coin, the less value the coin has, right? So by locking them up, you're not selling them. And in return for locking up your coins, you would get some reward for it. And I think there's other reasons to yield farm other than that. There's just an example. Okay, next is liquidity contribution. So decentralized exchanges need liquidity pools. This is just like they're holding coins for things like token swaps or lending, which we'll talk about lending in a minute. And this is how they guarantee that they have these coins on hand for these actions. If you allow your coins to be used in the liquidity pool, then you'll get some sort of reward in return. You'll probably receive payment in the form of like a portion of the trading fees. And then you can also get some other rewards. One is you can get a liquidity provider coin. This has like your share of the pool on it, and sometimes you get paid dependent on your share. So like someone who has 50% of the pool is going to make more off of the same whatever than someone who only has like 25, if that makes sense. Also, liquidity provider coins can be used for yield farming, which we just talked about. If you lock up your LP coin, then you would make more money off of the same thing other people are doing just because it's like a special coin, if that makes sense. And then also you could get a governance coin. So people who contribute more to these platforms could end up getting voting power because of its decentralized. Like no one's making the decision for you, so they let the users get voting power. But you have to contribute more than just being like a regular user. That's why you have to like earn a governance coin. You earn your vote. Next is lending and borrowing. So if you're looking for student loans, this is definitely not the way to go. But a simple example of this is you literally just put your crypto that you already own up for collateral, you take out that money, and then you would gradually pay back your loan. And as you pay back your loan, you would get your crypto back. If you don't pay back your money, then you don't get your crypto back because that was your collateral. And there are a lot of other ways you could do this. This is just like, again, just an example. Okay, tokenization. I really like tokenization. I think it's really cool. I think if there's one thing you take away from this, it's that like I feel like this is I think this is like the future, honestly. Like it's really okay. These are baseless statements, but I think it's cool. So basically tokenization, it shows ownership of a physical asset on the blockchain. You can make transactions involving assets way simpler and faster than you could in the real world. And this also lowers transaction costs. All of these things actually increase the value of the assets. So what are some things that you can tokenize? Like really cool stuff. First of all, commodities, which is like precious metals, oil, agricultural products. You can tokenize that. You can tokenize real estate. You can tokenize stocks, which I think is really cool. Luxury goods like art and collectibles. There's talk about like intellectual property tokenization. Like these are all really cool stuff. Again, this is not super mainstream right now, but it is like really cool, and I think it's somewhere that we could go with it. I don't know. Then there's flash loans. I hate these things. They're kind of confusing. Basically, how flash loans work is it's an uncollateralized loan where you borrow and pay back funds in the same transaction. So just to kind of define that a little bit, by uncollateralized, I mean you don't have to put up money for this loan. You don't have to put up money because of you're taking out and putting back the money in the exact same transaction. So if anything goes wrong in there, if you don't pay it back, whatever, the whole thing gets reverted. Okay? People use this to take out a lot of money at once because you don't have to put up collateral for it. I don't need $10,000 to take out this $10,000 loan, is the concept. People use this for a lot of things. We're going to talk about how it can be used for an attack later. But for now, an example of this that we can talk about is arbitrage. So basically, you take out a flash loan, right? You buy crypto on an exchange where it's cheaper, and then you sell on an exchange where it is more expensive. Then, in the same transaction, you're going to pay back that loan, and what you're left with is the difference between the crypto on the different exchanges, if that makes sense. Does that make sense? Yes. Okay, cool. Making sure. There are also, like I said, there are also other ways you can use flash loans, and we'll talk about like one of them later. You can use it maliciously, but okay. So, NFTs. NFTs are certificates on the blockchain that prove ownership of an item. This is like the art version of NFTs, but they're actually used like on a technical level. They're used for a lot of other things. They can be used for like your tokenization stuff. It's just used to prove your ownership of something unique. Okay? They have to be distinct, that's the whole point, and they are stored using a unique identifier, which is what makes them unique. And this is I think the art version of NFTs is cool though, so I am going to talk about it for a minute. Does anyone want to guess how much any of these cost? These are all NFTs on the blockchain. Lucas said $1 million. 1,035. You would think, right? Okay, these are extremely expensive. Someone made $52.7 million for putting words on a black background. I have so many words on a black background on this screen right now. Like, this is crazy. These things are actually expensive. They do actually have value somehow. I don't know. But just like, I just want to explain why it's not completely useless, because they do actually do something. So, does anyone think they're useless? I know I just said that was a lot of money, but does anyone still think they're like stupid and useless? Yes. Okay. Yes. No, this is my Discord profile picture, but I needed like an example. Okay, so basically that's me. That's my NFT I made. And then this guy wants to buy my NFT, right? So it's like simple, just pays me. I'm surprised this transition worked that well, honestly. Okay, so now I have coins. He has the NFT, right? And I understand everyone thinks that's stupid because why does he want it? But I think what we're missing is that, like, we already do this. Because, like, what if I was, like, a better artist, right? And then he bought, like, a better picture, and then it was for, like, cash. So we already do this. It's just buying. It's buying art. That's what it is. That's all it is. So just to be clear, a couple, like, ground rules, I guess, to make sense for NFTs. Person who bought the painting owns the painting, right? Same thing. Person who bought the NFT owns the NFT. Just because, like, I can buy a print of Starry Night, that doesn't mean I own Starry Night, right? It's the same thing. Just because you can screenshot an NFT doesn't mean you own it. That's the value in having it, okay? And then also, just to clear this up, because I think this comes up a lot, Starry Night is not technically copyrighted, but even if it was, this guy would not own the copyright to Starry Night just because he bought it. It's the same with NFTs. Just because you buy an NFT does not mean you own, like, the copyright ownership over it. You just own, like, the art itself. So yeah, I don't know. Does everyone still think it's dumb, or like does it make slightly more sense at least? Okay. Okay, thank you for your opinion. I don't think it's dumb. If you still think it's dumb, what if I told you that NFTs have real-world perks? Not all of them, some of them, good amount of them at this point, I would say. So sometimes proving your ownership of an NFT can get you something else. Like maybe it gets you perks in some sort of game. I don't know, maybe like a new skin or some sort of like power up, whatever the game is, I don't know. And then it can also get you access to exclusive events. So this is a real NFT. Yeah, see, he knows. It's a real NFT, and it gets you into real actual events in real life. So this is like a reason people will buy them, is because it's not just like the art thing, even though you would own like the art, but there's more to it. Moving on from my rant on NFTs, just because I feel strongly about it. But there are other things you can do on Web3. So DApps is a big one. These are decentralized applications. They're applications that are coded in smart contracts, and they are put on the blockchain. And they can do pretty much whatever you want. You're just coding on the blockchain. So some examples is Decentraland. That's a world-building game. We have Upland, which is a virtual real estate trading game. You, like, buy... It's very weird. You buy real estate that is real in the real world, but you don't buy the actual real estate in the real world. It's just like a virtual world where you own buildings that are real, if that makes sense. I don't know, it's kind of fun. There's also like music apps. So this one that I have on the screen is used for like helping artists connect with people who actually listen to their music. And then you can also do gambling on, everyone just looked up right now. I don't recommend this again. I don't recommend you do this, but you could do gambling with crypto. This is Polymarket. It's very funny. You can do everything from like sports betting to betting how many times Elon Musk will tweet each week. Like everything's on there. Yeah, it's funny, I think. Okay, there's a lot of other things you can do as well. One is there are decentralized autonomous organizations. So I talked about this with the governance coin, but a lot of times decentralized exchanges will let members make decisions for the platform. There's also soul-bound tokens, so these are non-transferable. They can represent achievements, your identity, your credentials. And this is where like self-sovereign identity comes into play. And again, it's not like super mainstream, but it's kind of up and coming. There's also cloud storage, which I thought was like really cool. So Filecoin is a decentralized storage network that's used for your cloud storage, which is just like so convenient and cool. The Brave browser actually uses, I didn't realize this either. Brave browser actually uses Web3 a lot. First of all, they pay their users in crypto for watching ads. They reward publishers with crypto. They protect your identity using a decentralized identity model, which is like how they do that. They have an on-chain naming service. I don't know this much about it. I tried to do research, but it was like a lot. They just do a lot. They also have like their own Brave crypto wallets. So yeah, if you want to look more into that, it's actually very interesting. I didn't realize they implemented that much, but they do. And then also there's oracles. So these allow you to use real world data on chain. So for example, we just talked about Polymarket. They get information on like the outcome of a sports game or something from an oracle. That's how they determine what actually happened in the real world. And we're gonna talk more about those later, so try to remember that. Okay, so like really quick, we're just gonna like learn a little bit about blockchain technology. I'll keep it really high level because, So there's two different ways you can mine or validate coins or transactions on the blockchain. One is proof of work and the other is proof of stake. So first, we're gonna talk about proof of work. This is used by chains like Bitcoin, Dogecoin, and Zcash. So pretty much your sender is gonna send their coin to a receiver. And this gets you, first of all, there is a transaction fee with that, so you need to keep that in mind. And then also this gets you transaction information. That transaction information gets sent to the mempool. Okay. Next, what's going to happen is your miners are going to select transactions that have the higher transaction fees associated with them. And what they're going to do is they're going to take their selected transactions as well as the hash from the previous block, because this is where we get the chain aspect of the blockchain. So you use the hash from the previous block in your new block to connect them. Each block has a secret nonce, which is hashed with the block header. So what the miner does is they are just over and over and over again, they are hashing the header with this nonce, and they're just trying to guess the nonce. It's just brute forcing, pretty much. Now, what you have to keep in mind is that you're competing with other people who are also doing the same thing. They might have a more powerful system. They might pick a different starting number that's just closer to the nonce. Like, it really is very arbitrary at a certain point. And they're just going to repeatedly hash the block header and the nonce, and Bitcoin uses SHA-256. In the end, one miner will be able to add their block to the blockchain when they guess the correct nonce, and this will in turn earn them the transaction fees from the block along with some extra Bitcoin. And this is not energy efficient at all. People have like huge data centers where this is all they do. It's such a waste. I don't know why. Bitcoin still does it, but then other platforms such as like Ethereum used to do it, and then they switched over to proof of stake, which is what we're going to talk about now. So proof of stake starts out the same, right? You have a sender wallet, you have a receiver wallet. You're going to send your Ethereum, right? And this also use like examples, Ethereum or Solana, both use it, also a bunch of other platforms. Again, transaction has a transaction fee attached to it. Transaction fee is chosen by the sender and is also paid by the sender. And in Ethereum, this is referred to as gas. So if I say gas, is what I'm talking about. It's the transaction fee. So this again, you have your transaction information, gets sent to the mempool, right? We already talked about this. We're experts on that part. This is where it gets different, okay? So what we have on Ethereum is we have multiple validator nodes that have staked their Ethereum. So pretty much they put up, it's a minimum of 32 ETH. They put up their minimum amount, and they say, I want to be part of the validator thing, okay? They want to do it. They want to participate. What happens is that now you can actually stake more than just 32 ETH. Before, it was just like minimum and maximum was 32. Now you can stake more. I don't know what the maximum is off the top of my head. If you stake more, you're going to be more likely to be selected to actually validate a block. It's not because of there's a bias towards people with more money. It's because of kind of like a raffle. If you have more tickets in a raffle, you're more likely to get picked. It's like the same concept. So basically what happens is you're going to select one node who is going to get to propose a block. So we're not racing. Not everyone's trying to do this at once. We're not wasting energy. One person is going to propose one block. That's it. Okay? So this selected node is going to choose transactions from the mempool, which have the highest transaction fee, because that's how they get paid the most money for proposing the block. Okay, so now they're proposing their block, and what happens next? Well, we want to make sure it's right, right? So now all the other validator nodes get to vote on if we actually like the block or not. If you're trying to do something malicious, then they'll catch you on that. That's the point. There's like checks and balances here. So if everyone likes your block and they vote that it's okay, it's valid, then you have a valid block. Congratulations. You get your Ethereum. Again, it's your transaction fee reward. And all is good and fine and dandy. We'll go back for the next block and someone else will get picked, and it's fine. If you try, maybe, I don't know, maybe you suck at setting up your node, maybe you tried to lie or something, whatever. If it's voted that your block is not valid, then the ETH that you have saved up in your stake will get slashed. So they will take, it's usually about like a little bit over 1 ETH they'll take out of your stake because of you did something wrong and you're being like punished. That's your consequence for not doing it correctly. And that's why you have to have that money locked up like that. Yeah, and that's how, I don't know, that's it. That's how the blocks are made. Does anyone, before we move on, does anyone have any questions about proof of work or proof of stake? Okay, cool. All right, so what are smart contracts? Like total 180 right now. What are smart contracts? It's literally just code on the blockchain. Like that's it. You code things, they go on the blockchain. Yeah, I don't know. It's not that complicated. There's a, I mean it is that complicated, but like not anything we're gonna get into today. Smart contracts, by the way, on Web3, just like a transaction, it gets like it's part of a transaction. Once it's validated, it would be validated. Then it's on the blockchain forever. It can't be taken off. So some smart contract coding languages, we have Solidity and Viper are very popular. Solidity is very similar to Java. I'm not saying it is Java, it's just like similar. And then Viper is more similar to Python. Some blockchains also use Rust. So if Rust is your thing, you could, yeah, like people here use Rust. So if you like that, I think like Solana, you can code smart contracts in Rust. Yeah, those are just some things you can get into. Web3 platforms. I talked about this earlier, but Bitcoin is not a Web3 platform, actually, because the the Bitcoin blockchain does not support smart contracts. So all you can really do on there is your like transaction stuff. And since there's no smart contracts, there's no dApps or anything like that, and therefore it's not really like this whole like Web3 environment thing. It's just like money transactions. Okay. Any questions about anything about Web3? Because I'm going to stop explaining Web3 and only talk about like security the rest of the time. Also, I hope you enjoyed the pictures because there's like no more. Okay, so really quick, I've said this like 3 times, but big new risk, their smart contracts are publicly visible on public blockchains. So anyone can look directly at the code for your dApps. If you write bad code, everyone will know, and they will know exactly what to do to mess with your stuff, okay? So this is positive. It creates a lot of trust. If anyone can see your code, like I said, anyone can determine if it's safe or malicious. It also is good for decreased fraud because if you post a malicious smart contract, other people are going to be able to see it. They're going to catch that. It's going to be obvious. Hopefully it's obvious. Maybe it's not, and they're really good. I don't know. Also a little negative. It's not great for privacy sometimes because of all of your transactions are super public. So if you were like a business trying to make some transactions that you don't want everyone to know about, that's unfortunate for you. Everyone can see it. Also, code visibility is just kind of a vulnerability for code because if you've turned like a black box type of thing into they can fully review your code. If there's a problem with it, they're going to find it way easier now. But let's get into these are all like smart contract vulnerabilities. So if you were like coding a smart contract or like reading a smart contract for someone else or whatever, these are things that you want to make sure you avoid. And there's a lot that actually overlaps with like concepts we already deal with all the time. So first is logic errors. This is like obvious, okay? Smart contracts, they have a lot of math going on. You want to make sure your logic's correct. This could end up leading to like incorrect rewards. Maybe you're like paying people too much or too little, or maybe your lending pool doesn't have the correct amount in it or something like that. Impact of this, you can lose money, or maybe your contract doesn't do what it's supposed to do. And this is really easy to fix. Just check your code, like make sure it's correct. And then also, you can use pre-created libraries and code snippets. So like there's no need to reinvent the wheel here. Like if it's a mathematical operation, just use a math library. Next is insecure randomness. So on Solidity, with Solidity, you cannot generate true random numbers, unfortunately. And this leads to a lot of people using pseudo-random numbers that are generated using some sort of information on-chain. We're going to kind of like touch on this with like very specific examples later, but just for right now, using things like block timestamps, block hashes, or the block miner address are bad ideas because they're things that could be manipulated, or they're things that could be predicted. So the impact of this is, yes, they could be predicted. Remediation, use off-chain factors. So we talked about oracles earlier. If you wanted something very random, you could definitely use some factor outside of the blockchain that someone couldn't control or that someone couldn't easily predict. Or you can actually use, there's a random number generator for smart contracts that's called Chainlink VRF. That's also another option if you want random numbers. Like there's just really bad idea to use on-chain controllable or predictable things for random numbers. So next is lack of input validation. This is when a user inputs like a not checked value, and then obviously it leads to some sort of unexpected outcome. Some examples of this is there might be like a missing range check. So if there's like an unreasonably high or low value, that could break the contract. Also with balance validation, you don't want someone to transfer more money out of their account than they have, right? Unchecked zero address is an interesting one. So the zero address is like a wallet that no one has the private key for. As we talked about earlier, if no one has the private key, no one's touching anything in there. So someone could like send money to this zero address, and then it would just sit there and no one can touch it. I don't know, like just to be mean, pretty much. I don't really understand why, but once it's sent there, it can't be recovered, and it's like kind of annoying because then nobody's touching it anyway. Then also missing authentication. So this could like let non-authorized users execute some sort of like privileged command or something. And for remediations, you should really only allow expected inputs within an expected range and format. This is very similar to like regular web concepts we talk about a lot. And then you should require user authentication for certain actions so that people aren't accessing functions they shouldn't really be touching. Another one is denial of service. Like we all know these. Like this is it's so transferable, right? So you're just exhausting contract resources. This could be, maybe it's contract, it could be gas, it could be the storage, or it could be the contract logic. And you're just gonna render the contract unusable and maybe lose some funds in the process. And then remediation for this, like you wanna limit gas usage and you wanna avoid unbounded loops. So with the unbounded loops, the idea is like someone could just run your contract so nobody else can use it, obviously. Okay, next we have integer overflow and underflow. This one gets a little funky because there is like in the newer versions of Solidity, they have like a solution for it. In older versions, they don't. So keep that in mind. But basically, overflow or underflow, you're either adding to the maximum amount of an integer or you're subtracting from the minimum amount of an integer. So if you have an unsigned integer that the max is 255 and you add 1, if you're using a version of Solana before 0.8.0, then it's going to wrap around to 0 as the value. 255 plus 1 would equal 0. And then same thing if you're using an older version of Solidity, then for an unsigned integer, if you subtract 1 from 0, it's going to wrap around to 255. If you have a newer version of Solidity, both of those are going to revert the transaction. It's going to fail. It's okay. But it leads to a lot of like contract manipulation, especially when subtracting gets you like a higher number. And then you also have to consider that this goes back to the input validation thing. You really should be making sure the input is valid before it gets this far that it allows like a wraparound type thing. But yeah, anyway, remediation, using the newer version of Solidity, definitely better. The newest version, we're at 0.8.33, so there's like a lot of options in between 0 and 33 you could choose. And then you should use math libraries also, talked about that before. And yeah, input validation too. Okay, access control. Basically, this is when your user's identity is not checked correctly or restricted, and you allow some sort of unauthorized action on your smart contract. So an example of this is there's like an owner-only function, but anyone can run it. Well, then it's not owner-only, everyone can run it, and this is going to cause a lot of problems. So impact of this, an unauthorized user could access some sort of restricted either data or a function. Probably you're going to lose money. Probably the contract's not going to do what it's supposed to do. And remediation, the first one on here is actually a little interesting. So you need to secure the initialization function of your contract so that it can only be called once. This is very interesting. There is an initialization function for the contract, and if you don't make it so that it's only run once, then an attacker can run that function again, and they will take ownership of your contract. So you want to make sure, like, when you initialize it, that's the only time that's ever run. Okay, and then this is just like, if you have some sort of application that has a front end on the regular internet, and then has some sort of like on the back end smart contract, whatever going on, you need to also make sure that your front end regular web application is also secure. If you don't, then it doesn't matter how secure your smart contract is, they're going to manipulate it on like the front end, the regular web end, and do whatever they want anyway. So like some examples, people have used like cross-site scripting, cross-site request forgery, or SQL injection to kind of circumvent whatever securities you have going on your smart contract. Yeah, it's just like, I mean, it's obvious, but it just needs to be said. So your front end needs to be secure as well. Okay, now new vulnerabilities, getting interesting. These ones are not something you would have like seen before so much. So first one is reentrancy attacks. This is when you have a function that makes a call to some sort of external contract, and before it updates its own state within the contract, it makes that external call. What that does is it allows the person to keep calling over and over and over again that external contract. So an example of this is you have this external contract that is just repeatedly making withdrawals until the smart contract is drained of all its funds. And you're able to do this because of your initial smart contract is never registering that it's actually like made that call and it's done. So I saw online, this is like a very cool idea, I guess, that all of your functions should follow the order of check, effect, and then interaction. So first, you want to check if there's any sort of conditions. They need to be validated first. Then you want to update your smart contract state. After you have updated the state of your smart contract, then is when you want to actually execute the external call. If you do it in the other order, that's what allows the reentrancy attack. And some remediations for this, you can update the contract state before making external calls, like we just said, and then you can also use reentrancy guards. So what these do is they lock the function during execution so that you can't make more calls on the function until it's completed running. Okay, next we have unchecked external calls. This is like very similar, but not exactly. So what this is a contract makes calls to an external contract, like we said, but it neglects to check that the return information is like valid before processing it. This goes to like input validation also. So basically you make this call to an external contract. If it results in an error and you're not checking that, then you're just proceeding with this invalid error through the rest of your contract. And it's not going to run properly. It's probably going to have some sort of inaccurate contract state. And also it just opens opportunities for other vulnerabilities to be exploited because of now like your contract's not running properly. So how to remediate this? You want to check the return value and implement error handling. And then also there's this really cool transfer function that actually like looks out for this. So the transfer function will revert external calls if they result in an error. If you use a function like send or call, it will not do that error handling for you. Okay, next is gas griefing. So if you remember, gas is like transaction fees, right? So what this does is an attacker provides enough gas to execute an initial, your initial, like if you have one smart contract, it has enough gas to execute that one, but any sort of subsequent external calls, there's not enough gas to execute those. So an example of this is like contract A is supposed to make calls to contract B, but I only give enough gas to execute contract A. Then the call to contract B is going to fail, and then you run into issues that we just talked about with like your unchecked errors and stuff like that. So remediations, a lot of remediations are like the unchecked external call kind of remediations, and then also you need to check the gas before making the call. It's hard to set like a minimum gas amount for a contract because the price of gas changes. Not the price of gas. The amount of, yes, the price of gas changes. So what happens is if the blockchain is more busy, like there's more going on, more people have their transactions in transaction pool, then you're going to need to provide more gas to do the same function if you want it to actually be executed in like a timely manner. Otherwise, if the blockchain's busy and you don't give enough gas for the like busy amount or whatever, then the transaction is just going to sit in the mempool until it's like the only one left, because if everyone's going to select the transactions that have more gas attached to them before yours. That was like very poorly explained, but I don't know if it made sense. Basically, like if the blockchain's more busy, then you need to give more gas for the same thing than if it was less busy. So that's why it's hard to set like this minimum amount. Okay, next is Oracle manipulation. We talked about oracles earlier, but as a reminder, oracles allow you to use real-world data on-chain, and smart contracts often use this information to trigger certain actions. So if an attacker manipulates the information coming from an oracle, then they could cause the contract to trigger some action when it shouldn't. An example of this, like a very highly conceptual example of this, is like, let's say there's a sports betting contract, you bet a certain team is going to win. Maybe you thought the Jacksonville Jaguars were going to beat the Bills, because I did. And when they lost, instead of losing your money, you just like sent fake data via the oracle to the contract, so you got the payout as if the Jacksonville Jaguars won, even though they did not. Okay. That's very conceptual. How it's actually really used is with flash loans, which is what we're about to talk about. But the idea is there that basically you're trying to feed the contract this false information that didn't actually happen, so you'll like trigger whatever action it is that you're trying to trigger. So remediation for this is you want to get data from multiple reliable oracles. There are cases where some contract is using like a very unreliable oracle, and you can like really manipulate the information, but for the most part, like you're not hacking an oracle, right? This is how it's actually really usually used. So reminder really quick, flash loans are loans where you withdraw money and you pay it back within the same transaction. There is no collateral that you put up, so a lot of people use this to take out very, very expensive loans, very high value loans. And if you think back to the arbitrage example where we took out a loan, we bought crypto on exchange where it's cheaper, right? And then we sold it somewhere it was more expensive. And then we repaid the loan, we kept the difference, right? That's what flash loans are used for sometimes. However, they can also be used to help an attacker manipulate blockchain logic in their favor to make the contract do something. So basically, an example of this is, let's say you have a smart contract that pays out if a certain coin reaches this certain price, right? Well, an attacker can take out a very big loan. They can put all of their funds into that coin, and then they would take the payout from the contract, right? Because of however big your loan was, it made the coin reach whatever price was on the contract. Then you would return the loan, and the price of the coin would like automatically go back down to what it just was. So you got the payout from the contract because of the price of the coin reached the price of whatever the contract was waiting for to pay out, but it didn't really reach that price because then it immediately went back down to what it was before. this is not something that's like unintended use. Like, okay, the argument with the flash loans is that they suck because of your contract is going to lose funds when the thing didn't actually happen. Other people can also lose money, which sucks too. It's very mean. But the argument with the flash loans is that they don't technically do anything you're not allowed to do. However, you can still code to protect your smart contract from falling victim to this. You should use reliable oracles, so they should be either decentralized, which means that they take information from multiple sources instead of just one, and then they come to a consensus. So if you did that, then even if you were very temporarily manipulating the price of this coin, right? So if you use multiple oracles that are all taking this consensus, then it probably would not register, like they would not all agree that the price of this coin was actually that price. And then similarly, you can use an oracle that implements time-weighted average prices. So this means that the oracle takes the average price over multiple blocks or minutes. So just because you, like, for 1 second made the price of this coin, like, super high, it wouldn't stay that way long enough for, like, a couple minutes to go by with it being that price. So it wouldn't ever register that you actually did that, really. And yeah, so basically the idea with the remediation is you want to prevent a single temporary transaction from impacting the value that is like read by the oracle. Okay, next is force feeding attacks. So you're forcing currency into a contract which is not supposed to accept it. Maybe it's not supposed to accept currency at all, or maybe it's just not supposed to accept as much as you're feeding it. An example of this is maybe this contract has like a game where, you know, everyone can only submit 1 ETH at a time. Whoever submits like the 10th one gets a prize, whatever, right? And then it's at like 7 ETH and you force 3 in. And then you get the payout and you won even though you like broke the rules of the game, right? So the contract balance will check because technically the balance of the contract is correct for the payout, right? It's correct for the reward. But what you don't want to do, and this goes back to something we had talked about earlier, what you don't want to do is you don't want contracts to do things based on the price of the contract because it's something on chain, it's something people can manipulate. The impact of this is that you're going to end up like paying people you don't want to pay, or maybe you could even like lose the functionality, the correct functionality of your contract. So what you don't want to do is you don't want to rely on the balance of the contract as a check. And it like kind of relates to the insecure randomness we talked about earlier because of, again, it's like that it's on chain. People can do something with it. Next one, access control, but different access control than what we talked about before. So basically on public blockchains, we said this, smart contracts publicly visible, okay? Hard coding any sensitive information or non-public information, doesn't even have to be that sensitive, would allow anyone to see it. So if you hard code your password, you hard code private API keys, you hard code some sort of admin address or whatever for your internal company, everyone can see it now. Those things are burned, they're gone, they're done, okay? You need to change them immediately. Everyone is going to attack your stuff. So this is really bad. Also just anything sensitive you don't want to put on there because that's information leakage. And it can lead to unauthorized access if you have like important passwords or like I said with the APIs. Remediation, you never want to hard code sensitive info on your smart contracts, ever, ever, ever. What you want to do instead is you want to use some sort of off-chain storage that will fetch the information, that your contract will fetch the information from. So people will not know the information itself. They'll just know like, oh, they're getting information from somewhere, which is like not a big deal. Okay, next is timestamp dependence. This is very similar to what we said with the I don't know, what was it? Yeah, force feeding. Very similar to what we talked about with force feeding. Basically, contract, again, depending on some sort of on-chain thing for a check. In this case, it's the block timestamp. So an example of how this could be used is maybe there's some sort of auction contract, and it relies on the block timestamp to end the auction. If a validator were to bet in this auction, right, so like let's say they put up their price and then they could choose to immediately propose the block after they put up their bid. I guess it's a bid. After they put up their bid, they could immediately propose the block, which would prevent other people from bidding, right? That would end the auction. But maybe it wasn't supposed to end at that time. They ended it prematurely because they have the ability to do that. So what this does is it gives validators an unfair advantage sometimes. And ways you should get around this is you want to use an external time source. You don't want to use the time of the contract or the timestamp of the contract as a check for stuff for this reason. And it's important to keep in mind, it really only is like 15 seconds that they can really play with, right? Like, it's not like they have an hour and a half to mess up your contract. It's like 15 seconds. But still, you want to prevent your contract from being able to be messed with in that short time difference. So maybe just don't make it so time sensitive that it's down to the second. In case you were wondering, this is OWASP top 10 smart contract vulnerabilities. I think we went over all this and also some extra ones. So just like FYI. Really quick, and I promise I will stop talking. How to secure Web3. What can you do? So some things you can do if you were trying to secure like a smart contract. First thing you should do, code review. You want to look over the code, see if there's any errors. It's like very obvious, right? Other things you can do, there are smart contract auditing tools. So just like any other like application or whatever that you have like SaaS tools for, you can have like a static analysis tool for your smart contract. There's also other ones that do other things. Testnets are like fake blockchains where you can test out your code. It has like fake money. So you can post your smart contract on a testnet and make sure it works correctly, and also definitely test edge cases, just to make sure everything's running correctly before you put it on the actual blockchain. Once it's on the blockchain, it's there forever. So like measure twice, cut once, right? Pen test, you can pen test smart contracts. You can use your testnet for this. You're just trying to attack it in like ways we talked about, maybe other ways, and then see what happens, if anything. And then there's also consultants. So there are smart contract auditing and pen testing companies out there. If for some reason like your company had a smart contract and they really like needed help with this, you could just hire someone else to do it and not learn it at all yourself. That's fine too. And then some next steps. So if you wanted to get into this, what should you learn? First of all, the coding languages. So you want to maybe you want to learn Solidity, maybe you want to learn Viper, maybe you already know Rust, so you're like a step ahead. That'd be cool. Blockchain infrastructure. I didn't explain that much of this, honestly, and I know very little compared to other people, so imagine how little contextualization was really given in this presentation. And then also, like, web app security is important. A lot of the concepts kind of carry over, like we talked about with all the familiar vulnerabilities. And then also, like, if your smart contract does have a front end, you should make sure that's secure too. This is like my last thing, I promise, I think. Yeah, it is. So there is one class here that you can take about cryptocurrency, and it's this. Guys, when I took it, it was a seminar, but I think this is the correct course code. I tried to look it up. What? Okay. Fine. Devin says you can take Finance 1 to learn about the blockchain. Oh, I don't know what he's saying. Okay. It what? Okay, it's back to a seminar. I don't know. It's always called this. Cryptocurrency Blockchain Analytics. You can try to find it. It counts as a credit for something here. I will say things you'll get a lot of exposure to is you'll learn a lot about, like, Bitcoin. We talk a lot about Bitcoin. It is a lot of, like, blockchain analytics is different. We do, like, digital forensics side of it, so it's a lot of, like, tracking transactions on the blockchain. What you're not going to get to do is you're definitely not going to touch a smart contract. You're probably not going to talk that much about Ethereum, honestly. It was, like, a lot about Bitcoin. But if you're interested, this is kind of your only option, so consider it. Also, you want to learn more about blockchain technology. YouTube is a great source, but when I say blockchain technology, I mean like learn about how proof of work works. I don't mean watch a get-rich-quick scheme online and then try it, right? So those are different things. And then if you need resources for coding, this website I have there is it lets you like code in Solidity. It tells you how much gas your code uses, and you can try to like run it. Oh, that's another thing. You know how like all the CS classes tell you about time complexity, right? And you're like, oh, I don't need to know this. This is stupid. Well, on the blockchain, actually, the more complex, the more it costs you to run. So you probably do actually want to know, what makes it the simplest to run. And then just last thing, there's some resources there is the OWASP top 10. And then the second one is like pen testing, try it yourself, smart contract stuff. So yeah, and then that's it. Are there any questions? Did anyone have a question?